Welcome to section 3.2. This should be a pretty nice section. Enjoy it, because 3.3 is coming. This is a good warm-up. It's a good preparation. We're going to be using this in sections to come. So we're going to start by graphing linear inequalities, and that's very similar to something that we've seen before. So we've seen what linear equations look like, y equals b plus mx, and we know how to graph them. Well, this section's not really anything new. That's a linear equation. A linear inequality might look something like y is less than or equal to b plus mx. So it's the same line. The difference is, instead of just looking at all the points that are equal to that line, we might look at all the points that are equal to or below that line, or something like that. So graphing is basically going to be the same. Maybe we put things in a slope-intercept form. That's y equals b plus mx. And then we'll just graph the linear equation like we've done before. Now, we'll sometimes use a dashed line. We'll use a dashed line if there's no equal sign, right? If the line is not included. And we'll use the solid line if that line is included. And then we'll just shade everything above or everything below, and we can test some things out. So let's do that here. Example 1, graph the solution to this linear inequality. So we'll start by just graphing the line itself. So what does y equals 2x plus 1 look like? Well, we have a b value of 1 that says our y-intercept, and again, we can label our axes. Our y-intercept is 1. The slope is 2. That means we go up to right 1, up to right 1, or we could go down to left 1, down to left 1. So we're already halfway through step 2. Do we use a dashed line or a solid line? Well, y cannot equal 2x plus 1. Y can only be smaller than it. So we're going to use a dashed line here. Okay. And that shows that this line is not part of our solution. Now, do we do everything under or everything over? Well, we should be smaller than this line. Everything below this line. So that's going to be underneath the line. So that's going to, I'm going to shade it in a different color just to make it a little bit easier to see. That's going to be this whole region. Everything below the line is our solution. Okay, and that's it. Any point in this red area should be a solution to this linear inequality. And we could test that out. Pick a point in this red area. Me personally, I like to pick the point 0, 0. I love zeros, and 0 should be a solution. It's in the red area. So the question is 0, is 0 strictly less than 2 times 0 plus 1? Yeah, 0 is smaller than 1. That's true. Okay. And that doesn't prove that our answer is right, but it's a good gut check to figure out whether we're on the right side of the line. And that's, in essence, what we're doing in this section, okay? We'll do one more example. You might want to try this one now. If you're feeling good about this, pause the video, do this one on your own. And then we have more examples in the next video. So, right off the bat, we had an optional step 1 here. Rewrite the inequality into something that looks like slope-intercept form. Notice this is in a bad form right now. It's not awful. You could plug in some points and get it. But it's not in the form y is by itself. So I'm going to make y by itself. Okay? So I'm going to subtract 4 from both sides. And that gives us x minus 4 is greater than or equal to 2y. And now I'm going to divide everything by 2. Divide both sides of the equation by 2. That gives us x divided by 2. X divided by 2 is the same as x being multiplied by a half. Subtract by 4 divided by 2. That's bigger than or equal to just y. And I'm going to rewrite it a little bit more. I like my variable to be on the left. So if this whole thing is bigger than y, that means y has to be less than or equal to that whole thing. Okay, so this is our step 1. And now we can graph this more normally. The y-intercept is -2. Again, this is our x-axis, this is our y-axis. It's good to label those. And our slope is 1/2, which means we go up 1, right 2. Up 1, right 2. Down 1, left 2. Down 1, left 2, and so on. Do we use a solid line or a dashed line? Well, it's greater than or equal to. And actually, really, I should say it's less than or equal to. So we're going to use a solid line. We do that. It looks like this. Do we shade everything under or everything over? We should be smaller than this line. We should be underneath this line. I'm pretty sure I can use this little tool. Whoa, look at that. I'm really fancy now. All right, so it's everything that equals this line or is under this line. It's this whole yellow area. I can make different colors too. Oh, I'm going to use that. I'm learning technology. How about that? Okay, and then again, we could make a little test point. What's something that's in this region? 0, -4, maybe? That's in the yellow region. That should be a solution. So let's look at the original equation. Is 0 greater than or equal to -8 plus 4? Is 0 bigger than or equal to -4? Yeah, -4 is smaller than 0, that's for sure. Good. It's a good idea to just do little test points. And that's basically it. Let me know if you have any questions, and we'll do some more practice in the next one.